Class 10, Chapter 1, Real Numbers, Exercise 1.3, Question number 2. Prove that 3 plus 2 root 5 is irrational. To prove this question, we will first assume that 3 plus 2 root 5 is a rational number. We know that a rational number can be represented as a by b, where b is not equal to 0 and a and b are co-prime integers, which means 3 plus 2 root 5 is equal to a by b. Now, this can be further written as 2 root 5 equals a by b minus 3. Dividing by 2 on both sides of the equation, we will get root 5 equals a minus 3b divided by 2b. Since a and b are integers, a minus 3b and 2b are also integers. This is true because of the closure property of integers. Integers are closed under addition, subtraction, and multiplication, which means that when an integer is added, subtracted, or multiplied by an integer, it always gives an integer. So since a and b are integers, a minus 3b, where subtraction and multiplication has been used, and 2b, where multiplication has been used, always gives an integer. Since a minus 3b and 2b are integers, a minus 3b divided by 2b is a rational number. This is because a rational number can be represented as a fraction in which both the numerator and denominator are integers and the denominator is a non-zero integer. Now, we know that root 5 is an irrational number. Since a minus 3b by 2b is a rational number and root 5 is an irrational number, the equation root 5 equals a minus 3b by 2b does not hold, which means that our assumption that 3 plus 2 root 5 is a rational number is a wrong assumption, and 3 plus 2 root 5 must be an irrational number. Hence, we have proved that 3 plus 2 root 5 is irrational by contradicting the assumption that 3 plus 2 root 5 is rational.